So, two new factoring patterns. Factoring by grouping. It is a scientific fact that 99% of human beings can remember three numbers. That's why your locker combination is made of three numbers. That's why your social security number comes in three parts. That's why phone numbers come in three parts. As soon as we take it to a fourth number, you lose almost everybody. People have much more difficulty remembering 4 in a row than they do with 3. So that's the reason they work the way that they do. So what we're going to do is we're going to trick our brain, because we're going to see that factoring by grouping has 4 terms. And that's where our brain says, sorry, out to lunch. I can't look at all 4 of those and figure out what it is that's supposed to be factored out there. 3, I'm okay with. You multiply to get the last term, you add them together to get the middle term, but you throw a 4th in, we're toast. So we're going to trick our brain. We're going to split it into 2 groups of 2. So our brain will say, oh, that I can do. I can do 2 here and 2 here. That's no big deal. And then factor out the greatest common factor in each of those terms. So we're trying to see, did we notice the exact same factor was there? And then we're going to use what's left to make sure that we can get back to the original that we just factored. And then it says the GCFs form one factor, the common what's left is for the second factor. Yeah, all of that stuff is best if I just show you one. You'll see what on earth it is we're trying to do. So, example 1. Here's what we do. We look at it and we say 3, 2, 1, 0. Oh, I can't put any of those together, and my brain doesn't like 4. All right, so here's how I'm going to trick it. I'm going to group the first 2 together and the last 2 together, and see if I can get my brain to see there really is something that will divide out of all 4 of those terms. So I look at just 8x cubed minus 20x squared, and I try to factor it. And I realize, well, I can take a 4 out of that, and I can take an x squared out of that. So I'm going to take 4x squared out of those first 2 terms and see what's left. Well, 4x squared times something gives you 8x cubed, and that something is 2x. And then 4x squared times something gives us negative 20x squared. Well, that's minus 5. Now, I'm not done, and my brain still can't see what on earth is going on until I factor the second group. So I look at my 6x minus 15, and I think, well, I can pull a 2 out of that. Sorry, a 3. Thinking ahead to the next step here. Pull a 3 out of that. And if I do that, 3 times something is 6x, and that something is 2x. 3 times something is negative 15, and that something is negative 5. And now the light bulb comes on. My brain can now see 2x minus 5 was really in both of those parts. So I can see that that's a factor. Now it's not there twice. Remember, we had to pull a trick on our brain to get it to see that it's in both of those pieces. It's just there once. So it's like we're going to take this 2x minus 5 and we're going to factor it out into the front. And then we have to put what's left, which is the 4x squared and the plus 3, in the other set of parentheses. Because this always has to work forward and backwards. That's math. So if we can factor this and get this, we should be able to do FOIL on this and get back to the original. That way we can kind of check our answer and make sure it's going to work. So, major trick on the brain. Over here, this looks pretty scary. There's all kinds of variables going on here. But if I remember 4 terms that I can't put together, and I group them, I think, well, there's an A in both of those first terms. I'll just pull an A out of that. And it'll be x plus y. And then these back 2, well, I definitely see a B in both of those, and I can pull that out. And then it's, oh, good, I tricked my brain. X plus y was really there the whole time. I couldn't see it because there were 4 terms. But the piece that's going to give me that is this A plus B, the leftovers. What did we use to see that, to make sure it was going to work? So let's go down to example 2. any of those together, or any of those like terms? All right, so then when we see four terms, we should say, you know what, I'm going to have to group this. My brain can't see the factor that's there. So 5m cubed minus 10m squared. What did we take out of both of those? And I heard some people say the 5, and I heard some people say the m squared. So together we've got all of that. So what would be left in here? Minus 2. Because 5m squared times m is 5m cubed. 5m squared times negative 2 is negative 10m squared. What could you take out of 8m minus 16? All right, let's take an 8. If you do that, if you factor the 8 out, what's inside the parentheses? We can see it. Originally, when we saw this thing, there's no way anybody said, oh yes, m minus 2 divides that nicely. We can't do that. Usually some people that they'll call like mathematicians that can do that, but for most people, we have to see that it's in both parts for us to say, yep, it really was a factor. You know, I had to trick my brain into seeing that. And then, what did we use to make that happen? Mike? 5m. We sure did. So there it is. And it doesn't matter. Some people like to put the 5m squared plus 8 in front of the m minus 2. So, if I were you, I would be saying, okay, Cyril, what happens if we do all this and these parentheses don't match? Then we can't factor by grouping. Then we have to use different methods. But today's about factoring by grouping, so most of them should be factored by grouping. All right, let's take a look at this one. Can we put any of those together? Oh, cubic, squared, end of the first, no like terms. But let's see what we can do. We got big numbers for that second part, huh? 6n cubed plus 24n squared. What you got, Mike?
6n squared.
Oh, you're going to take the whole 6. Can we take the 6, everybody? Yeah. Sometimes you think stuff like 2 and 4 first, and then you realize, oh, wait a minute, I can go bigger. So 6n squared. If we pull that out of there, what's left? N plus 4. Look good, everybody? Okay. So now, that looks obnoxious in the back. It is easy. What do you take? You do. Now, before I do the rest of this, if you're thinking, well, how on earth am I supposed to know that? Remember, this parenthesis has to match this one or we can't do it. So that means that 21 has to be pulled out or we won't be able to factor it. Do we get n plus 4? So how do we write the answer? N plus 4. Yep. The piece that we saw when we tricked our brain, and then the leftovers. Oh my goodness, that looks scary. That's a lot of gum. So first thing I look at is, can I put any of these together? Well, this is a WX. No more WX's. XZ squared. No more XZ squared. WY? Nope. Nope. They're all different. So we have to try, since it has 4 terms, factoring by grouping. 6WX minus 14XZ squared. What are we taking? 2X? What does that leave us with? Minus 7. That's a lot of stuff. Well, let's see if we get the same stuff in the back. What could you pull out of 15WY minus 35YZ squared? What's left? That sounds familiar. There it is. We see it, same set of parentheses. Now, I do want to warn you, every once in a while, these both have negatives, and you'll have to pull a negative out of both of So make sure your parentheses have exactly the same thing in them. If they don't, then we can't factor it by grouping. And again, it doesn't matter if you put the 3w minus 7z squared first or second. There it is. So 43210 means the objective so far is just factoring by grouping right there. Do you get the feeling that you've maybe seen this before? Kind of getting that little feeling in your head? So you don't think you did this in exponential? Some teachers have to skip it because they don't have time. Any of you have the feeling that you've seen factoring by grouping before? Okay. All right. Now, another new factoring pattern. We look at it and we don't see squares. But what we do see is perfect cubes. So a cubed plus b cubed, a cubed minus b cubed. That's going to grab our attention. Two reasons. First of all, we're not as comfortable with cubes as we probably should be. So let's say that somebody looks at 64 and they don't know if it's a perfect cube. Remember, on your calculator, because we talked about this when we were doing powers before, underneath the math button for number 4, right there, that's cube root. So if you don't know whether or not 64 is a perfect cube, you can always do that and you'll get 4. Now, I don't think they gave you huge numbers for this today because I wanted you to feel pretty comfortable. Oh, there's a couple of them here you might not like. So let me stop. And we're going to say, well, this is really weird because this is cubic stuff. We haven't done cubic stuff before. And this is a formula that most people do just memorize. Now, I try not to memorize. So what I do is use logic. And I look at a cubed plus b cubed and I think, well, somewhere in that thing, you must be able to pull out an a plus b. I mean, there's 3 of them, for goodness sake. There's got to be one a plus b in as a factor. And then I think, okay, now working backwards, how would I get that to be a cubed plus b cubed? Well, if this is just an a, this is going to have to be a squared. And if this is just a b, this is going to have to be b squared. It's the only way it's going to work. And then I think, if it doesn't have a middle term, I'm going to have to use the opposite sign for that middle term. Otherwise, everything is going to have lots and lots of terms. So that means I'm going to have to, since this is plus, use subtraction of the 2 of those multiplied together. So again, some people just memorize it. I try to think logically about what's going to happen. This one says a cubed minus b cubed. Okay? If there's 3 of them, there's got to be at least one factor that's just a minus b. So thinking backwards, a times something has to give me a cubed. That's a squared. B times something has to give me b cubed. That's b squared. And the middle term has to drop out. So if this is a minus, the middle term has to be a plus. And it'll look like that. So if you can, use logic instead of memorizing. That's just always the best thing to do in math, is to think logically about it. So this shows us why it works. I'm not going to bother you with that. That's a lot of algebra with variables there. We're just going to get into practicing this. So we've got factor, for example, 5, x cubed plus 125. Well, I can only do that if 125 is a perfect cube. Is 125 a perfect cube? What is it? Cube. 5. So this is x cubed, and this is 5 cubed. And I remember, oh, this is the one where I need the formula. Okay, so this is plus a cubed plus b cubed. That means there's going to be an a plus b in there somewhere. Now, what do I multiply a by to get a to the 3rd? A squared. What do I multiply b by to get b to the 3rd? B squared. But my middle term has to have the opposite sign. Otherwise, I'll have middle terms, and I don't want that. So this will be minus ab plus b squared. Now, why do I use that? Because I need a formula to put these into. And I just found the formula. There it is. So a is really x and b is really 5. And we're going to put them in the formula and simplify as we go. So this is just going to be x plus 5. Then we have to take x and square it. Then we have to subtract x times 5, which is 5x. And then we have to square b. It was 5, so that's going to give me 25. Mike, did you have a question or were you already filling in? Okay. Now, the question always comes up. Is that one still factorable? Because we're supposed to factor as long as we can. Well, you can try it. You can think for a second. Two numbers that multiply to 25 and add to negative 5. I'm going to tell you 98.5% of the time, we're done. We can't factor at this point. These are usually not factorable. Now, I say that, and there's always an exception. So every once in a while, one of those quadratics will be factorable, but it's once in a great while. So just stop and ask yourself, are there two numbers that multiply to 25 and add to negative 5? Nope, not going to work. I'm done. It's factored. Let's go to the next one. 8m cubed plus 343. Well, the first thing I would want to do is divide both of those by 8. Does 343 divide nicely by 8? No. All right. Well, how about we try another number that divides 8 nicely? 4. Is 343 divided by 4? Can we at least make this smaller? No. How about 343 divided by 2? Well, we already know it's not going to work because it's not even a number. So we're stuck with 8 and 343. And we should realize, well, 8's not so bad. Then what do you cube to get 8? What do you cube to get 8? 2. 2 times 2 times 2. So this is 2m cubed. And we have a calculator, so if we don't know 343 as a perfect cube, we can do math. Number 4, 343, and the calculator will gladly tell us that that is 7 cubed. And then it's back to logic, where you say, all right, if this is a cubed plus b cubed, there has to be an a plus b somewhere in all of it. And if I'm working backwards and I need to get a to the third, I'm going to need 2 more a's and 2 more b's. And I'm going to have to make sure that my middle term is the opposite of what I have in the first parentheses. So it's going to be minus a b. And then we substitute. A is 2m and b is 7. Numbers are getting a little bigger, so we want to make sure we're careful about this. What's going to go in the first set of parentheses? 2m plus 7. And now here's where we have to be really, really careful. What is 2m? The quantity squared. 2m times 2m is 4m squared. See, everybody always wants to put a 2 right there. 4m squared. Minus, what's our middle term going to be? 14m plus, last term, 49. And I do want to remind you, because that one, you can't just say, hey, two numbers multiply to 49 and add to negative 14, because there's a term in front. Remember, you can always do the discriminant. And if the discriminant turns out to be a perfect square, then you know it's factorable. So, we do a little b squared minus 4ac on our calculator and see whether or not we get a perfect square. So that will be negative 14 squared minus, parentheses, 4 times 4 times 49. And it's negative, so it's definitely not a perfect square. So this one is done. We are finished. We've gone as far as we could possibly go. Oh, next one looks smaller there. That's kind of nice. All right. So n cubed minus 216. 216, is that a perfect cube? This is n cubed. What do you cube to get 216? 6? Yeah, and again, if you didn't know it, you get math number 4, 216. There it is, it's 6. my formula is going to be slightly different this time, because if this is n cubed minus something, that means I have to have a minus b in the first set of parentheses. And then I've got my a squared in the front and my b squared in the back to make sure that I'm going to get a cubed plus b cubed. But I have to use the opposite sign in the middle, which will be a plus ab. So that's the only difference in these two formulas. It's the location of the plus and the minus. Plus u. So first set of parentheses would have what, everybody? N minus 6. First term for the second set, n squared plus 6n plus, there it is. And this one you can check just by hand and say two numbers that multiply to 36 and add to 6. Not gonna happen. So that one's done. Ooh, 27x cubed minus 64. Is there anything we could take out of both a 27 and a 64 to make this smaller? Might not want to, right? Because what do you know is cubed to get 27? 3. What do you cube to get 64? So maybe we don't want to find anything anyway. 3x cubed, 4 cubed. Should I put subtraction in the first set of parentheses or the second set? First, right there, that tells me. So what's going to go in our first set of parentheses? Yep. Now be careful. First term, good. 9x squared. You have to think 3x times 3x. Plus what? 12x. Plus, there it is. Again, just to be sure, you could b squared minus 4ac. Make sure that that's not going to be factorable. So 12 squared minus parentheses 4 times 9 times 16. Again, we get a negative number. We know we're done. That's not a perfect square. So that's going to be 2. All right. I am impressed. I am impressed. Look, I'm looking out here and everybody's heads are down and you were doing these last 3 before I even wrote the formulas down. I already know about you guys that you are great visual people with the graphs, but you also seem to be really great formula people, and that's going to help you out a lot with this. So, a little practice. Here's what I need you to do though. Don't follow the directions the book has, because they're going to say factor and solve. We didn't do the solve part yet. So for 11 through 19, just factor those and then stop. And then go to a couple of review problems in 61 to 67 there. So I know it's hard because you want to read the instructions in the book and do what they're doing, but all we've done so far is factor. So just factor 11 through 19. I won't try to do those all the way through.